Well, good morning, ladies and gentlemen. Thank you very much for the invitation to speak at your conference. And thank you. And I also want to congratulate the organizers with the arrangement and the conference program. And I must say that I feel honored to be a part of that. The topic of today is health and safety dilemmas and challenges. The Norwegian petroleum industry's ambition is to be world leading in the oil and gas industry, as Bo just said, for health, safety and working environment based on a zero accident philosophy. And my organization, the Norwegian Oil Industry Association, will of course try to work and contribute to achieve that goal. Addressing health, safety and the working environment issue and identifying best practices throughout the value chain and add value to the results on the Norwegian continental shelf. However, sometimes excellent health and safety initiatives may lead to contradictory health and safety results. And this talk will try to describe or illustrate different situations and examples that I have experienced where health and safety scenarios are associated with conflicting interests. And I've divided my talk into three main sections, each one illustrating or trying to illustrate different conflicts or dilemmas. And firstly, what I want to do is to give you some examples from drilling. Secondly, I will look into some challenges related to helicopter transport. Thirdly, I will move on to helicopter underwater escape training. And finally, I will try to sum up some main conclusions. And I'll be glad to take any questions at the end of my presentation. Right. Let us start with the first point, which is related to drilling. And as you all know, approximately 90% of the chemicals supplied to the well site are used during drilling operations, in particular in the formulation of drilling fluids. And current oil and gas industry initiatives aim to ensure that the occupational health hazards of chemicals use are minimized. And during drilling operations, a large volume of drilling fluids is circulated in an open or semi-enclosed system at elevated temperatures with agitation and therefore potentially exposing workers. And drilling fluids, as you all know, and I know there are a lot of drilling experts and specialists in the audience, so you have to excuse me. But as you all know, drilling fluids are a key requirement in the vast majority of drilling operations for controlling down-hole pressure, removing drill cuttings from the hole, lubricating the bit, and other critical functions to ensure a safe and productive well. So you can't do without them. And you have water-based fluids generally used in the upper hole sections of the well, with non-aqueous fluids used, that is based on, well, mainly I think hydrocarbons, in the more technically demanding hole sections. At least this is the main situation or general situation on the Norwegian continental shelf. In addition, talking about personal exposure, as drilling has become more complex, and especially in the long sections, with increased temperatures, and when drilling more reactive formations, the number of additives, that is more chemicals, has increased rapidly in number and in complexity. In trying then to quantify occupational exposure hazards from drilling fluids by the study and analysis of the base fluids and product used in the drilling fluids may not be completely representative of the drilling fluid as used in the field, because hazardous substances may also be present from the formation being drilled. For example, hydrocarbons. As a purpose of drilling a well is to produce hydrocarbons or to find them first. One known source of hydrocarbon contamination will be from the reservoir formation. And these hydrocarbon sources can provide oil, condensate, and gas contamination in a drilling fluid. And please be aware of that gases from formations are primarily methane. Why do I go into such details? Well, the key words that I want you to remember is hydrocarbons, gases, vapors, elevated temperatures, vapor pressure, boiling points, air, oxygen, etc. Personnel being exposed to drilling fluids may be exposed either by inhaling or aerosols or vapors or by skin contact. But the highest potential of inhaling mist and vapor is along the flow line from the bell nipple to the solid control equipment. And I would like to draw your attention to the shaker house. High hydrocarbon mist and vapor exposure levels have been reported in the shaker house, and I'm sure you're familiar with these kind of operations. And the main exposure opportunities are while washing with high-pressure guns or cleaning and checking screens. And at each stage of a drilling operation, if hazardous components of the drilling fluid have been identified with the risk of worker exposure, the following hierarchy of controls should be considered. And you know them all: elimination, substitution, engineering control, administrative controls like hygiene measures, working hours, and finally, personal protective equipment. But concerning engineering control, ideally, the design of the workplace should incorporate all the engineering controls required to minimize exposure of hazardous substances to the workforce. And over the recent years, many new technologies have been developed to address inferior work environment conditions. And one of these is the mud cube. Have you seen this before? This is not a commercial, it's just an example. But this system works, this thing does the same as these components do. So you do see the difference, don't you? From a working environment perspective. So with its vacuum system, the mud cube is a totally enclosed unit. Compared with a vibrating mud shaker, it is very quiet. And the system is designed to transport and process drilling fluids in a manner that protects the work environment through reduced vibrations, acceptable noise levels, and no chemical emissions to the working environment. And the operation and performance of the mud cube, it also assumed to be more cost-effective than traditional shale shakers through reduced mud loss and better filtration. So far, this is just great, isn't it? From my point of view, it is. Do you see any showstoppers, however? Anyone? Yeah, coming to that. That's simple. Cleaning of it is simple. But in this situation, we got an enclosed box. We have a complex of hydrocarbons mixed with air. And we may have a lot of methane coming back together with the mud being returned. And there are mechanical moving equipment working, that is, able to produce sparks. In other words, we may have created a huge explosive device here. And it should be noted that several physical and chemical characteristics affect the major risk of an explosion. And these should always have first priority and be carefully assessed and monitored. And the prime concern of any operators and the Norwegian Oil Industry Association are to prevent major accidents. So, huge concerns and efforts were put into this issue, and they managed to solve it because someone thought that something else that we're not only going to take care of the working environment, but we have to think safety at the same time. Thinking two things at the same time, that's difficult, but you have to do that. But I have to stress that they succeeded. And these results can only be classified as an outstanding success. And the first vacuum shaker is now being installed and operated at one of Statoil's installations in the North Sea. And this is an example of introducing a vast improvement of the health and working environment conditions for workers that could have resulted in an increased risk of major accidents. But I've also encountered the same problem complex in other situations. And you're all familiar with old rigs built on the open vent principle. And this one is actually the first rig that went operating on the Norwegian continental shelf. And these rigs operate under circumstances where the removal of gases, aerosols, vapors have relied on open atmospheric ventilation. That is, it's windy in the North Sea, so it's getting blown away. And when the wind blows the ignitable gases away from the installation, this reduces the risk of a major accident. From a risk assessment perspective, the wind acts as one of the barriers. However, it may be cold working out there in the North Sea, and you know that, and I know that. And therefore, at some rigs, I've come across panel fences that have been built in order to reduce the exposure to the challenges climate. And the working conditions for the workers have improved dramatically. However, I have seen several examples of rigs not being designed for such panel fences. And these designed amendments have resulted in creating confined spaces with explosive atmospheres, which was really not the intention. I think this covers more or less everything I had to say on the first item, and I'll move forward. Let's look at another dilemma derived from a completely different part of our offshore activity. The operations in the North Sea depend on helicopter transport to and from the installations. And every 10th year, a helicopter safety study is being performed in Norway in order to summarize results of the present and anticipated future risks associated with civil helicopter transport of personnel in the North Sea. And recommendations are given on how to improve the offshore helicopter flight safety during the next decade. A new study is about to be published these days, but the conclusion is not yet available. But the general opinion is that helicopter transport on the Norwegian continental shelf is on the top world ranking when it comes to safety. This implies that helicopter passengers are transported to and from the installations under maximum precautionary measures, being optimal and best equipped, in order to survive helicopter emergency landings at sea, so-called ditchings, to escape from the helicopter body, and finally, also to survive and escape from hypothermia. Helicopters are technically much better today compared to before, and floatability has been improved, and thereby the time available to get ready to evacuate a helicopter, including getting this survival suit ready. Despite these technical improvements and achievements, helicopter transportation is recognized as the highest risk activity on the Norwegian continental shelf. So therefore, all efforts must therefore be made to reduce the risk exposure and prevent major accidents. In 2003, the Norwegian Petroleum Safety Authority sent a letter to all the oil companies with notifications of order stating that the rescue of personnel from the sea should commence no later than 30 minutes after an accident. And this statement implied that the survival suits had to protect personnel in the sea from hypothermia for 120 minutes, based on the assessment that the rescue operation will be completed within 90 minutes. And the industry therefore decided to send out a manifest which stated that it was mandatory to keep up the survival hood and to zip the suit up during takeoff, landing, and during shuttling. And this decision was based on passenger safety, and the object was to reduce water penetration in the survival suits in the event of emergency landings at sea. But in 2007, some of the oil companies operating on the Norwegian continental shelf started to question this topical recommendation and reviewed to change the procedure from having the hood up, zip up during landing and takeoff to just having to zip up this suit. The matter was discussed, but it was decided to maintain the recommendation. However, OLF decided to execute tests of a new survival suit, the so-called HHCR suit. That's one. These tests were performed here in Esbjerg in Denmark, and the test jumping from 3-meter heights with the HUD up and without the HUD up showed all acceptable results. You didn't have any water penetration. And additional tests were also performed during the helicopter underwater escape training with the HUD up and with the HUD off. In these tests, however, the average results proved marginally not acceptable with respect to water penetration. So, the recommendation was kept. Why discuss such an apparent detail? Isn't the main focus passenger safety? Why bother with some discomfort related to having the survival suit zipped up and hood up, while the main issue is to prevent water penetration and hypothermia in case of ditching? Well, the survival suit hood up means that passengers will be protected with only one set of hearing protections, plugs, which means that the exposure to noise is considerable, because you cannot wear ear muffs on top of the hood. The annual report from the Norwegian Petroleum Safety Authority has detected an increase in the incidence of new noise-induced hearing losses, in addition to a registered escalation of existing injuries. Thus, there may be a relatively high probability that helicopter transportation of personnel may be a major contributor, inducing damages from noise every year within the oil industry, that is in Norway. So it's important to focus on preventive measures considering health due to the fact that reduced hearing capacity will lead to a strongly reduced quality of life. And concerning helicopter transport, the heaviest noise exposure is while waiting in the helicopter, on the helideck while the helicopter door is open, and when getting off or on the helicopter offshore. And individuals are not protected with double hearing protection during transportation from to the helicopter with the engine running. And to reduce the noise exposure, individuals should use double hearing protection when being in the cabin, when the door is open, and when moving to and from the helicopter. But there is a third problem here, because in addition, the communication between the helicopter passengers and the pilot is important, especially during emergency situations. And the Civil Aviation Authority in Norway has really focused on or emphasized that it should be possible for the pilots to communicate with passengers in the cabin over the personal address system, the PA systems. But information given on the PA system is very difficult to catch when the hood is up. However, the double hearing protection equipment is usually, the earmuffs, is usually connected to the PA system in the helicopter, so this makes communication possible. And OLF's aviation experts therefore recommend to keep the survival suit hood off during takeoff, landing, and transportation. As per today, the OLF's recommendation is that passengers shall have the survival suit hood up during helicopter departure and landing to reduce the risk of hypothermia in event of landing at sea, ditching. However, We have received feedback from several oil companies that want to remove the survival suit hook-up requirement in order to improve the receipt of messages over the PA communication system, and also first and foremost to avoid inducing noise damages. And all the professional experts within the Norwegian Oil Industry Association, that is health, industrial hygiene, aviation, emergency preparedness and safety, have come together and decided on a conclusion, and that is that the OLF recommendation for hood up is withdrawn and a new best practice with focus on noise protection should be established. Which brings me to the third and final dilemma, which is also related to survival suits, but at this point connected to helicopter underwater escape training, so-called HUE training. How many people here has ever been to this kind of training? Can I ask for a show of hands? Yeah. Well, from this simple opinion poll, I can see that a majority of you are quite familiar with what I'm going to talk about now. And I would like to draw your attention to the survival suit and its design and equipment. And the Norwegian Oil Industry Association has developed minimum requirement specification for the design and efficiency of integrated survival suits for the Norwegian continental shelf. The design of the survival suit shall be adapted to the ergonomical needs during normal activity, before, during, after transportation by helicopter, during evacuation of the platform, when in the water, and during rescue. And the following specification or equipment apply to the integrated survival suit used in the offshore activities are that it should be produced in different size so that it should fit female and males and with all ranges of sizes. The suit shall be designed to prevent more than 200 grams of water from penetrating into it when it has been donned properly. The suit design shall not cause a reduction in the comfort so that the suit represents a safety or a health risk. This implies to thermal comfort during long flights with strong irradiance. At the same time, the suit shall provide the user with thermal protection in the water. And the suit shall have an integrated breathing system so that it will be possible for each individual to have a better capacity rather than just to hold your own breath. You should have a spray hood, and the suit is also fitted with a pocket for a personal locator beacon, which is fitted on the suit when handed out on the heliport. And if I could just digress for a second, are you all familiar with the problems related to personal beacons which was experienced on the UK sector? Because following the ditching of an offshore helicopter in the UK sector in February last year, the investigation authorities looked into the matter, and they discovered that the passengers' personal locator beacons may interfere with the long-range rescue beacons that are fitted into the helicopters and the life rafts. They were effectively shutting them down and can therefore impact the effectiveness of search and rescue operation. And it has now been made clear that the interference during the ETAP ditching was which caused the main aircraft and life raft beacons to switch off, was caused by the fact that the beacons were with a smart type. And this smart technology is designed to shut beacons down if they detect another beacon signal within a certain radius. Moreover, this problem has been solved. And there was a press release from Oil and Gas UK just a month ago. So there are personal local locator beacons are now back in use. I chose to mention this incident as it illustrates another dilemma between safety intentions and results, since incidentally, this safety equipment actually turned out to cause a potential serious impact on the effectiveness of the search and rescue operation. Well, let me come back to the requirements of the survival suits. We have a lifting strap, we have a body line, we have an inflation system, including a tube for inflating the suit by the mouth. And we also have a lot of things related to buoyancy and righting, so that the suit is supposed to give the user a stable floating position lying on the back. So as you can all see and understand, the Norwegian survival suit is very well equipped. I just missed an engine, because then you can go along, get on shore by yourself. Excuse my sarcasm. But the design and material used in the chosen design of the suits shall not contain any elements that can be expected to have a detrimental effect on the operation. But this applies in particular to protruding suit parts that can get caught or represent a danger during flying and during emergency evacuation from helicopters and platforms. And such parts shall be properly covered, protected, or fastened. However, when we are examining this suit, we all see different protruding suit parts, don't we? And I have personally observed people being suited up, ready to evacuate the helicopter through one of the emergency exits or windows. And please be aware of, they're only 40 centimeters wide. And I've seen this happen, both evacuating the helicopter in the air, well, not while flying, of course, but and underwater. And people has been caught in the emergency exit due to different protruding suit parts, or due to air accumulated on the inside of the suit, making it even more voluminous, to the detriment of the passengers trying to evacuate. And I've seen 2 passengers, they were about to drown because they couldn't get out of the window. They weren't fat, they were like me, but the volume and the things on the suit made it too difficult to get out. And I also saw another guy, he got his rib fractured because he was struggling so hard to get out of the window that he actually injured himself. And my question is, how big a risk is acceptable during training? I have given you a fairly detailed instruction or introduction into the Norwegian requirements and philosophy related to survival suits for offshore activities. And briefly summarized, this philosophy, it states that a survival suit should be able to protect against hypothermia for 120 minutes when having to evacuate into the water, into the cold water. On the other hand, the survival suit is so well equipped that you may experience trouble getting out of the helicopter and into the water. And I'm familiar with emergency and rescue philosophy on other sectors that are based on concerns and principles to make it more easy for people to get out of the helicopter and rely on the fact that people are picked up after a short period in the sea. And personally, I would prefer to wear a swimsuit when doing my helicopter underwater escape training. And there is, of course, no right and wrong answers to the questions related to the survival suit. And that brings me to the end of my presentation. What I tried to do today is to try to share some experiences with you in order to hold promise of a higher awareness and understanding of important health and safety issues and potential conflicts. And my hope is that all HSE personnel thoroughly considers every aspect of the operations and working conditions in order to ensure high health and safety standards. And I hope this has been useful to you, and thank you very much for your attention.